Hello everyone, today I'm going to talk about a problem from the Norwegian Mathematical Olympiad from last year, and it's about filling of a board with chips. So there is a board n by n and it is initially empty, and at each step you put a chip in some empty cell. You execute the steps until the board is filled with chips, and at each step you receive I plus j points if there were I chips in the same row and j chips in the same column before you put the new chip. What are the possible total scores that you can get when the board is filled? So this is a problem from it's called the Abel Competition, and it's also known as the Norwegian Mathematical Olympiad, the final round 2019 problem 1. Okay, so the idea is to count the total score in a different way. So we have the board, and let's select some row. It can be any row, and for now we are going to count only the points that are contributed from this row, meaning that for each chip that was put in this row, from the I plus j points we are counting now only the I points that are due to the already existing chips in the same row. So let's enumerate the chips in that row in the order that they appeared. So we have number 1, number 2, number 3, and so on. So chip number 1 contributes 0 points because in that row there was no other chips before. So chip number 2 contributes exactly 1 point, and chip number 3 contributes 2 points, and so on. And the last chip number n, contributes exactly n minus 1 points. So when we sum all of these together, we have 1 plus so on plus n minus 1, which is n multiplied by n minus 1 divided by 2. This is the number of points contributed from this row that we selected. So similarly we count the points contributed from any column. So any row and any column contributes exactly n multiplied by n minus 1 divided by 2 points. So when we sum all of this together, we obtain that this n squared multiplied by n minus 1 points, and we notice that this number does not depend on the choices of where the chips are put at each step. And we are done.